Alright, so here's a problem. We have to figure out the protons, neutrons, and electrons in various isotopes. So I'm just going to make a few columns for each. We're going to go through the process. So the first thing is, if it's written in this format, this bottom number is known as the atomic number, and it's the number of protons. So we can simply write that from the bottom number. So chlorine 17, barium is 56. If it's not written in this format, plutonium, we have to look up on the periodic table and find the number of protons. So when we do that, we see that plutonium is number 94 on the table. That means that's its atomic number, and it has 94 protons. So we find that. So protons is always the easiest, generally. If you know the name of the atom, you know the protons. That's required, that's dictated. Now the neutrons, the protons and neutrons together add up to the top number. This is known as the mass number. So the mass number is just the sum of the protons and neutrons. So together, the protons and neutrons have to equal this number. So what plus 17 gives you 35? So if we subtract 17 from 35, we find there are 18 neutrons, because 18 plus 17 is 35. Here my number is 137, so I have 56 protons. So I have to calculate how many neutrons there are. So I'll subtract 56 from 137, and when I do that, I get 81. And I just double check, does 81 plus 56 equal 137? Yes. This is the mass number for plutonium here, at least this isotope. So 239 minus 94, I get 145. So 145 neutrons, 94 protons. You'll notice that there are usually either an equal number of neutrons or more neutrons than protons. That's not always the case, but it generally happens. Now electrons. Electrons are, and protons together, determine the charge of an atom. If there are an equal number of protons and electrons, there's no charge. Electrons are negative and protons are positive. So this particle has a -1 charge. Now we're not allowed to change the protons because they're dictated by the atom. There's 17. But to have a -1 charge, well then we're going to need more electrons than protons. And so we'll need 18, because 18 versus 17, the electrons sort of win by 1. In other words, you have one additional electron, which explains this -1 charge. Here we have a +2 charge. Again, the protons are set in stone, so how many electrons will it take to be +2? We must have fewer electrons, so there are 54. There are 2 more protons than electrons, hence the +2 charge. When something is written in this format, we assume, or if there's never any information about the charge, we assume it's neutral, or 0. So in that case, the electrons have to balance the protons, and there will be an equal number, and that's sort of it. Another thing just to notice is on the periodic table there are a lot of decimals. Like for example, for chlorine you get 35.45. You cannot use that number on any of these types of problems to talk about specific chlorine atoms. That's the average mass of chlorine, of all chlorines. In this case, this specific chlorine has a mass of 35. Like if you're ever using a decimal for proton, neutron, electron counts, stop. You're not allowed to do that. The only thing you can get from the periodic table are the protons on these types of problems. So, till next time, I am Derek Genova. Have a delightful day.